Welcome and good morning to all SYBSc students. Today we study last point of this chapter. The name of point is Lissajous figures. Okay. Now these Lissajous figures are obtained when we subject a particle to two perpendicular SHMs. That means we have to consider the composition of two SHMs which are mutually perpendicular to each other, and under that we have to subject the particle simultaneously. So first the particle obeys the oscillation, and path of that oscillation depends upon frequencies, amplitude and phase of the two SHMs. Okay, that means first we have to subject the particle under two SHMs, and these two SHMs are mutually perpendicular to each other. Then path followed by the particle depends upon the frequencies, amplitudes and phases of these two SHMs. Okay, now first we have considered the frequency in the ratio 1:1 and then frequency in the ratio 1:2. In that both application we have obtained number of figures, and that figures are called Lissajous figures. Okay, now then we see application of these Lissajous figures. The Lissajous figures are used to compare the frequencies of two AC signals with the help of CRO. Okay, that means when we know the frequency of one signal, then we can determine the frequency of other signal. And so these Lissajous figures are used for the printing purpose on a cloth to design beautiful design on the cloths. That means with the help of Lissajous figure we can draw beautiful design on the cloths. Okay, these are the two applications of Lissajous figures. Now next we consider these Lissajous figures are obtained by two methods. So first we consider first method, that is the optical method, and then we consider second method, electrical method. In optical method we are going to use two tuning forks whose oscillations are electrically controlled. Okay, now we see first method, that is the optical method. This optical method consists of a source, that is the lamp, then a slit S1. The slit has hole at the middle. Okay, then next is the convex lens L. Then tuning fork, first T1, then second T2, and last one is the screen on which the figures are traced. Okay, so when light from lamp L passes through the slit S1, then it incident on a convex lens L. This convex lens L focuses the light on mirror M1 of tuning fork T1, and this mirror M1 is attached to the one end of tuning fork like this, right? Then light after reflection from mirror M1 incident on mirror M2, which is attached to one prong of the tuning fork T2. This mirror is M2. And oscillation of this tuning fork T2 is also maintained electrically. Similarly, oscillation of tuning fork T2 also maintained electrically. Then light after reflection from mirror M2 incident on a screen S2. Okay, in this case the two tuning fork T1 and T2 are mutually perpendicular. Then that means their plane of vibration are mutually perpendicular to each other. When these tuning forks are at rest That means they are not oscillating. That time we see the spot on the screen. Okay? And when these tuning fork T1 and T2 are set into oscillation by electrically, then we get the different figure on the screen. Okay? So whatever figure we obtained here, that depends upon the frequencies, amplitudes and phases of these two tuning fork. Now here the phases, that means these T2 and T1 are perpendicular to each other, then their phase difference is 90 degree. Okay? Then frequency of oscillation and amplitude of both tuning fork are different. So then we obtain the different figure on the screen. So this is the optical method by using which one can obtain the different figure on the screen. So these figures are called Lissajous figures. Okay? So this is the optical method in which we use the light source for illumination purpose. Okay? And there are two tuning forks on which mirror M2 and mirror M1 and M2 are attached on one end of the tuning fork. Okay? So this is the optical method. Then next we consider electrical method. In electrical method we use the CRO, that is cathode ray oscilloscope, and this is the CRT tube. So first we consider the structure of the CRT tube. In structure, the first part is the filament F, which is connected to the low tension battery. The next part is the gun, through which the beam of electron passes, and this gun is connected to the high tension battery, so that whatever electron emitted by the filament, they are accelerated by this gun, and after acceleration they passes through the collimator. Okay? Then next part is, that is the two vertical plates X1 and X2, and there are two horizontal plates Y1 and Y2. Okay? And last one, there is a screen of the CRT tube. Okay? Now we see the working. Okay? Now here this X1 and X2 are the vertical plates to which we have to connect the supply or AC signal. That means one voltage we connect to the vertical plates, and other voltage or AC signal we connect to the horizontal plates. That means here two AC jumps that we consider. The first AC jump is one AC signal, and other AC jump is the other AC signal, which are connected to the horizontal and vertical plates respectively. Okay? Now when without application of the AC signal, where we switch on the CRT, then this filament emits the electron, and this electron get accelerated through the gun. After passing through collimator, they passes through the two plates and finally incident on the screen. Now first we consider without applying the AC signal, then we will get the spot on the screen. And when we apply the two signals having different frequency, amplitude and phase, then due to these two signals or two AC jumps, this beam of electron traces different path on the screen. That means we will get the circle, ellipse, straight lines, parabola, etc. And that depends upon the amplitude, frequency and phase of the two AC jump. That means here we have to take two signals. Okay, two AC signal, and by varying their frequency, amplitude and phase, we get the different figure on the screen. Okay, so here we get circle, ellipse, two straight lines, parabola, etc. right? And that depends upon the phases, then frequencies and amplitudes. Okay, so this is the electrical method in which we are going to subject the beam of electron under 2 AC signal, that is 2 AC, that is 2 AC jumps. Okay, so you will get the different figure. So this is the electrical method, this is the CRT, that means cathode ray tube. Okay, so this is the electrical method, right? So with this lecture we stop here, and this is the last point of this chapter. Then remaining are the examples. So I will solve example and send PDF to you. Okay, so thanks to all.